Alright, hello, and welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for the following session for today. Again, if you're tuning in for the first time, thank you so much for watching. Thanks for tuning in. If you're tuning in for the first time again, just a little bit about ourselves here at OneClass. What we're doing here is we are educators, and what we're here to do is we are here to verify some frequently asked questions about topics such as in math and the secondary level, and as well as in chemistry at basically the secondary school level and also the university and college level. So it's kind of a little bit about us, and we're going through a series of kind of answering questions through our teachers here at OneClass, and we're here to kind of verify solutions as we move forward. Just a little bit about myself. Again, my name is Joey. I'm currently a secondary school educator in Ontario. My topics of interest or my teachable subjects are chemistry, as well as I'm hoping to get math as well when September comes. And yeah, so for this video, what we're going to do is we are going to kind of break this off into the first hour is going to probably be about pre-algebra questions and algebra 1 questions, maybe some geometry questions as well. So basically about grade 8 and grade 9 math. And then for the second hour of the video, when we come back at about 12 Eastern, what we're going to do is we are going to move on to harder level math. So this will be kind of the end of algebra 2 and pre-calculus, so about grade 11, grade 12. Kind of questions that you would probably encounter in high school. So without further ado, let's get started on today's problems. Again, we have 10 problems for you today. All right, here. So we have the first question here is asking, what is the square root of 24? Square root of 24. So just give me a second here. Might have to replug something, but it says, what is the square root of 24? So again, we're already pretty familiar with radicals. We're pretty familiar with this topic of simplifying radicals in the in terms of the we're familiar with simplified radicals using simplified radical form. So that's what I'm probably going to do first before we kind of get started for today. So it says, what is the square root of 24 here? Just wait a second here. There we go. What is the square root of 24? And this solution here, again, is calculating the exact decimal place of square root of 24, and I'll walk you through the solution as well. But I'm also going to show you what the simplified form of 24 is. So in order for us to break a radical down, again, we're using this concept of prime factorization, right? We want to break these guys into basically factors that are prime numbers. So prime factorization. So 24, again, it's an even number, so I can break that down into 2 and also another number, right? So I can say that this is equal to root 2 times whatever 24 divided by 2 is, which is root 12 here. And then as you can see, we can break root 12 down because this is another even number. We can take another 2 out, right? So we'll have another root 2 here. 12 divided by 2 is root 6. And then finally, I could break root 6 down into root 2 and root 3, but I'm going to choose to stop here just because root 2 and root 3 can't be broken down even more. So I'm just simply going to simplify this this radical here. So I have root 2 times root 2 here would give me simply just 2. Is my pen working here? Don't know if my pen's working. Sorry about this, folks. Let me see if I can. I think it's a little frozen, sorry. But this here is just simply just root 2 times root 6, right? So this here is simply, I have to refresh this. But again, this root 2 here, root 6 here, it's going to simplify into root 2 root 6 here. That's going to be my answer for this question here. And I'm going to show you what the prime factorization is first for the question here. Just give me a second, some technical difficulties here. See if we can do blue. Nope. guess this menu's just frozen. All right, I have to refresh the page. But this answer here is just simply 2 root 6, right? Again, square root of 2's cancel out, and we have so we have simply square root of 2 times square root of 2 is obviously just 2, and 2 root 6 here would be our answer for this problem. So let me just refresh the page. I don't know what's happening here. Maybe it's bugged or something. Yeah, my pen's not working out today for some reason. Let me try it on a different browser. Sorry about this, folks. But, okay. Almost got it. Here we go. See if it works on Chrome here. So again, we have square root of 24. Yeah, there we go. We got square root of 24 here. And then we broke this down to root 2 and root 12, and then we broke this down to root 2 times root 2 times root 6 here. And again, root 2 times root 2. Again, I can cancel these out and just simply put 2, right? You can, and then I have 2 times root 6 here, which is kind of my prime factorization, or the simplified radical form of root 24. So this here is my answer for this problem here. If you want to calculate the decimals, again, this student did it themselves. They used the method ask solution here, where you take, you basically do a kind of a long division, but with a kind of a spin to it. So again, you have 4 times 4 here. 4 squared is 16. You have a remainder 8. You double the quotient here, or double the quotient here, so 4 becomes 8 here, and then you can bring down imaginary zeros here, and so you have 8, and then you're figuring out what number goes into 800 here, and you realize that 88 times 8 here, both of these guys would be 8, so you have 4.8 here. 88 times 8 is 704, and then what you're going to do is again double this the 8 here. And you get 16, you add this by 80, you get 96, and then the next number you have 90, you can bring down another 2 zeros here, and you have 9600, and you realize that 969 times 9 is 87721, and this would be approximately 4.89. So this is how you would square root something in terms of if you want to solve for the decimal places. If you want to do the simplified, again, simplified radical form here, 2 root 6 here is our correct answer. So I'm going to say here, solution here is correct. Solution is correct. Good analysis. So solution is correct. Let's move on to number 2. I guess I'll use just Chrome now because I think Firefox is bugging out the board for some reason. That's okay. So this point G is the centroid of the triangle. AG equals 5x plus 4. GF equals 3x minus 1. What is AF here? So let me just draw this out first. So we have a triangle like so. And then the centroid, let me see if I can approximate this. Oh, that's a bad line here. We'll use the line tool here. It's not really centered, but it's the best I'm going to do here. As you can see, it's not the best thing here, but totally fine for the purposes of this here. So this is a centroid here. So going to move A, B, C, and this is F and G here. It's asking us if AG is 5x plus 4. So if from here to here is 5x plus 4. And then from G to F is 3x minus 1. From here to here is 3x minus 1. What is A to F? So A to F here. So what is the red here? What would this length be here? So all I'm going to have to do is I'm just simply going to add up AF here is simply just AG plus AF, right? It's this section here, AG plus GF here, right? So it's going to simply just equal AG plus GF here. And as you can see, G's to cancel out, which would equal AF here. These two G's would cancel out, and you get AF here. So this here would be correct. Again, I'm simply just adding polynomials, right? I have 5x plus 4 plus 3x minus 1 here. 5x plus 3x here would equal 8x here, plus 4 minus 1 is minus 3. So this here is my solution, right? AF here is 8x minus 3 is my solution here. So this here is correct. 8x plus 3, there we go. Then AF is x equals plus 3 here. Do they want us to solve for x or just give you this here? Let me just check the solution for a sec. So it says, according to the property of centroid, median is divided to 2 divided by 1 by the centroid. Yeah, so this is correct as well. So when we're talking about the centroid of the triangle here, we realize that 5x plus 4 and 3x minus 1 here, again, they have it's a 2 to 1 property. So what that means is that this length here is double the length it has a 2 to 1 ratio, so it has double the length here. So basically what they're doing is they're setting up a proportion. So let me just walk you through the math here. So you have 5x plus 4 divided by 3 is in ratio with 3x plus 1 here, and basically what they're going to do is they're going to then cross multiply. So let me just show you this here on the side. So we have 5x plus 4 over 3x minus 1 equals 2 to 1, right? So they're going to cross multiply. So they're going to 5x plus 4 is going to go on this side, and then you have 2 times 3x minus 1 that's going to go on this side here. And once you do that, you can solve for the x value, right? So you have 5x plus 4 here equals, this is 2 times 3x here is 6x, 2 times negative 1 is negative 2. And then what you're going to have here is 5x minus 6x. If I bring 6x to this side here, I get minus x here. Plus 4 to the other side would give me negative 4. So I'd have minus 6 on this side. The negatives cancel out, and x equals 6 here. So if x equals 6, what I could do is I could solve for my AF, right? Because I know it's 8x equals 8x minus 3. So I can substitute basically the 6 into this equation here. So I would have 8x minus 3. 8 times 6 here minus 3. Finally, 6 times 8 here is 48 minus 3, but therefore AF here would equal 45. So this here would be my final answer for this problem here. They got 51 here. Oh, this is plus 3? Yes, this is plus 3. Oh, my bad. This is plus 3 here. 4 minus 1 is positive 3. This is plus 3. So therefore this would make it 51. Sorry, my fault. Didn't do my algebra correct here. So this solution is correct. Solution is correct. Good analysis. Okay, that's question 2. Let's look at question 3. It says I have 18 ones, 15 hundreds, 15 tens, 8,000s. What number am I? So it says here 18 ones, 15 hundreds, 15 tens, 8,000s. Okay, so what we can do is we can say 18 ones is simply just equals 18, right? 18 times 1 here is 18. 15 hundreds is 15 times 100, right? So 18 times 1 here is 18. 15 times 100 here is 1500. 15 times 10 here would equal 150. And 8 times 1,000 here would give me 8,000. And simply you can just add up all of these numbers here to get your answer, right? So you have 18 plus 1500 plus 150 plus 8,000 here. So you get a value of, let me see if I do this in my head. This would be 9668 would be my answer, I believe. Yes, 9668 here. So if I add all these up here, the number here is 9668. So this here is solution here is correct. Is correct. Great analysis here. Okay, let's do number 4 here. This is a farmer with 750 feet of fencing wants to enclose a rectangular area, then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens here? So I have 750 feet of fencing. and I want to enclose a rectangular area, then divide it into 4 pens, right? So I have here, so I have to enclose a rectangular area and divide it into 4 pens with fencing parallel to one side of the rectangle. So what is the largest possible total area of the 4 pens? So again, if we're talking about area here, we want to maximize the amount of side lengths of our kind of enclosed quadrilateral. So what we're going to have to do is we're going to have to actually, instead of a rectangle, what we're going to do is we're going to make a square. So basically all of our 4 sides here are equal. So this would be x here, and it's x here, right? And we have, again, 750 feet of fencing. So in order for us to do this, again, I would have to have kind of a square here. And it says here I have to divide it into 4 pens with fencing parallel to one side of the rectangle. So it means that I'm going to have to split it up either this way. So I'm going to divide it up into four pens, right? So I have 1, 2, 3, 4. Or I can divide it into 1, 2, 3, 4 like that. So I would need kind of I need to build a pen with 4 compartments here. So again, I have 4 pens here, 1, 2, 3, and 4. So again, and this is in a shape of a square here, right? So it says here, this is correct, right? So to build a pen with 4, we need 3 identical vertical lengths here and 3 identical horizontal lengths. And these are all the same lengths as the side lengths, right? Because they're parallel to one side of the rectangle. So therefore, we need 6 lengths of identical fencing, right? So that's correct, because we need 3 vertical and 3 horizontal, right? Like kind of like this. So I have 1, 2, 3, and then 1, 2, 3 going like down here as well. So if I have 750 feet of painting, again, I have 6 individual parts here. So I'm going to divide 750 by 6 here to get me 125, I believe. 750 divided by 6 here is 125. Good. 125 feet here, which is going to be parallel to the side length, right? Because if I know that this is 125 here, my x would equal 125 here, because again, there's the same length for my sides, right? So if I have 125 feet for one of the sides here, I can simply calculate the area, right? The area is simply length times w for a square. In this case, length and width are both the same, right? So it's 125 times 125 here, which would give me an answer of 1,565 or 15,625, sorry. And this is square feet. So this here is my correct answer here, and they have the correct answer as well. So this solution is correct. Solution is correct. Good analysis. All right, that was number 4. Let's look at number 5 here. What is 1.6 as a fraction? So 1.6 as a fraction. Let's take a moment to think about this question here. What is 1.6 as a fraction? So how I would convert this is I would convert kind of I'll look at the decimal first, right? So again, we have 1.6 here. So we have our decimal place is here, right? So what we can do is, 1 here is my whole number, so I can just leave that for now. And then I have 0.6, right? It's 0.6, again, this is in the decimal place, right? So I have in the first decimal place. Therefore, I have 1 0 in my kind of fraction here. So the first decimal place here is a tens digit, right? So which means I'm going to have this here 6, and it's going to be 0.6. So it's 6 tenths of a 1.6 is simply 1 6/10 as a fraction here. This is as a mixed fraction, because I have a whole part and I have a fraction part, and what I can do is I can convert this into an improper fraction, right? If I were to convert it to an improper fraction, so just everything as one fraction, what I could do is I can simply do 1 here times 10. So 1 times 10 here is 10, plus 6 is 16, right? So this would be 16 divided by 10 here. And this would be my improper fraction for 1.6 as a fraction. So this here will be my correct answer. And it says here, in the given case, 1.6 can be converted into fraction form. 1.6 equals 16 over 10, which is good. And they even reduced it to 8 over 5 here, right? So you can reduce this to lowest terms. So let me see. Reduce to lowest terms. So as you can see, again, 16 and 10, they're both even numbers. I can divide both numerator and denominator here by 2. This would give me 8 over 5 here. And this solution is correct, right? 8 over 5 would be equivalent fraction to 16 over 10, which is 1.6 as a fraction here. So this solution here is correct. Good analysis. All right, that's number 5. Number 6 asks, how many feet are in a football field that is 100 yards? So how many feet are in a football field that is 100 yards here? So again, when we do a yards to feet conversion here, what we need to know is, again, we're working in the imperial system. Therefore, I know that 1 yard here equals 100, or 1 yard here equals 3 feet, right? So this here is a common kind of conversion here. So if I have 1 yard equals 3 feet here, and I have 100 yards, how many feet do I have here? So if I have 100 yards here, I would have to simply convert. I can use, again, dimensional analysis to help me figure this out, right? I have 100 yards here times how many feet per yard? I have 3 feet per yard, right? So I have 3 feet per 1 yard here. And this would give me, again, the yards would cancel out here. So I'm left with feet here, which is what I want for my answer. I have 100 times 3 here, which is simply 300 feet. So how many feet in a football field? That's 100 yards. 300 feet is the correct answer here. They got this right as well. So 1 yard equals 3 feet. We can multiply 100 yards by 3 feet per 1 yard for dimensional analysis here, right? So we are essentially multiplying by 1, but doing so allows us to cancel the yard unit so that we're left with feet. So this here is correct, right? This here they actually use dimensional analysis here, which is great. So good solution. Great use of dimensional analysis to figure out units. All right, number 7 here says, when constructing inscribed polygons and perpendicular lines, how are the steps similar? So I have here inscribed polygons and perpendicular lines. So when I'm constructing them, when I'm making these shapes and these lines here, how are the steps kind of similar? So so it says here, the answer here, it says a very, very vague answer. It says both involve using compass to cut arcs, intersect them, and connect them. So this here is kind of right. So again, when we're talking about inscribed angles and inscribed polygons here, what we're gonna have here is inscribed polygon is simply just a polygon inside another shape, right? So we can look at this as so I could have something like this, like a circle here. If I drew a circle here, and what I'm going to do is I have a polygon. Let's say I have, I'll have an angle first, right? So let me draw an angle here. I'll draw from here to here, and from here to here. So some angle, this here would be some angle here, right? Between these 2 points, here is some type of angle here. Let's say maybe angle theta here. And then what I can do is, if I have an angle that's inscribed in a circle, then the vertex is in the center of the circle here. So again, I have the center of the circle. I can maybe assume it's here. And then what I can do is I can see that I can basically form kind of my triangle here, or my this center of the circle would be my centroid of the triangle here. So I can inscribe, again, this is a polygon, or in this case a triangle, inscribed in a circle here. So, or if you were to think about polygons, you can think of it as I could have a quadrilateral in my circle, right? So if I change this here and make this kind of like a quadrilateral in my circle, so I have some sort of shape here in my circle. So again, a quadrilateral here, and I can say here that the quadrilateral lies kind of like here. There we have supplementary angles. Opposite angles are so here maybe I'll write this down here. So I have this is B, C, and D here. I can say A and C here. These two angles here are supplementary or opposite, and B and D here are also supplementary. So A and C here, like cross here, this here are supplementary angles, and this here are supplementary angles here. So these are all opposite angles here. So that's kind of inscribed polygon. So how are the steps similar in when we're constructing perpendicular lines? Again, perpendicular lines are simply just kind of like 90 degrees. We have lines that intersect in terms of a 90 degrees, right? So this here would be an example of a right angle here, perpendicular lines. So what we can say about this problem here is that the steps are kind of the same, but it's not very. This is how are the steps similar here. So what I can do is I can use what I would use to basically draw a circle is I would use a compass, and then using compass is correct. So using a compass to draw a circle would be correct if I were to do this on a piece of paper, obviously, and not on a tool like so. So using compass to draw a circle would be correct. Also use of a ruler to connect to create chords and angles and turn them into inscribed polygons would also be needed. Creating or constructing perpendicular lines also require the use of a ruler, and even like a protractor and a protractor as well, right? To ensure angle is 90 degrees. And basically you also use a protractor to let me type this out. You would also use a protractor to measure angles of the inscribed polygon. So again, you would basically need a compass, a ruler, and a protractor here. So these are all steps or tools that are similar to create inscribed polygons and also perpendicular lines. So the solution here is, I'm going to say it's correct, but it's kind of empty, but it's okay. 7 here says, what is the square root of 625? Again, what we can do here is, I'm going to assume, again, it's using this, we're talking about simplified radical form here. I have here 625. The first factor I would probably take out here is 5, right? As you can see, all numbers that end in 5 and 0 are factorable by 5, right? So if I take a 5 out here, I'm going to get 625 divided by 5 here, which is, I believe, 125. Again, I have another 125 here. I'm going to take out another 5 here. So take out another 5 here. I have now 125 divided by 5, which is simply just 25. And then now we have here this is square root 25. And we have simply 5 here times root 5 here. And times, we all know the square root of 25 is simply just 5, right? So we times 5 here. Square root of 5 times square root of 5 here is simply just 5. 5 times 5, so these two cancel out, and this should equal 625. So square root of 625 here is equal to 25, and this here is my answer for this problem here. This solution is also correct. They even did plus or minus, which is actually better. So plus or minus 25 is technically the correct answer, right? I have 625 here. I'm taking out a 5, taking out another 5, and then I'm left with square root of 25 here, which I know for a fact here is 5. So this here solution here is correct. Okay, that's number 7. Let's look at, this is number 8 here. It says, is there a number t that is exactly 1 more than its cubed? Justify your answer. This would be 8. So it says here, is there, oh, sorry. Is there a number t that is exactly 1 more than, I guess, t cubed here? It says justify your answer. So if I have t here, if there's a number t, let's assume it's 1 here. So if t equals 1 here, then I have t cubed would be 1 cubed here, which is simply just 1, right? And I want a number that's exactly more than 1. Okay, so 1 clearly doesn't work, right? Because it's not 2, right? So what if I tried 2? So if t equals 2 here, then I have t cubed, which is simply 2 cubed. 2 cubed here is 8. So again, it's not 1 more than 2, right? I want it to be equal to 3. That's not good. Let me try 3 here. So if t equals 3, then t cubed here would be 3 cubed, which would give me 3 cubed is 3 times 3 times 3, which is 27. So as you can see, this is a series that kind of diverges, right? So you have 1 cubed, it gives us 1 here, which is good, but not good enough, right? I need to have 1 more than t cubed, right? And then I'll have 8, so which means the gap is getting bigger, and 27, the gap is getting enormous here. If you did this with negative numbers, you would get the exact same thing. You would get basically, you get t equals -1 here. T cubed here would be -1 cubed, which is simply just -1, which means you're getting the exact same answer as well. So in this case, there's not a number that is exactly 1 more than t cubed, as proven kind of by this guy here. So it says a number does not exist. To prove this, solve the equation. This yields the following solution: 1 equals 0. Therefore, it is impossible here. So we could do this trial and error thing, or we could basically we can create an equation, right? So we can say, is there a number t that is simply t here, which equals t cubed plus 1? And we could simply just do, we can kind of solve this problem here by taking basically t to this side here. So I have 0 equals t cubed minus t plus 1 here. And then basically you would solve this solution here to figure out if it does actually solve, and you realize it's actually not factorable. This would probably be actually, I would say, probably a grade 12 question. So don't worry if you don't kind of get this problem here, but you can kind of use trial and error in terms of exponential numbers here. We know our exponents here, so we can actually use this to kind of prove this guy here. So this solution here is correct. Good analysis. All right, that was number 8. Let's look at number 9 here. We have 3 more questions. It's pretty good. It says, which order pair makes both inequalities true? Okay, so let's look at 9 here. So I have inequalities I have here. This is y. Y is less than -x plus 1, and then y is greater than x here. So I have these 2 conditions, and which order pair makes both inequalities true? So let me try a here. So a here is -4 and 7 here, right? So this is my x value and my y value. So let's look at the first one guy here, the first term here. So this is 1, and I'll do, I guess this is red is 2 here. So in the first restriction here, the first inequality here, y here, which is simply for a is 7, is less than -4 plus -4 plus 1. So I have 7 here is less than -4 is 4 plus 1. 7 here is less than less than 5 here. And this solution will not be correct, right? This here would not, option A is incorrect because this here is 7 is not less than 5. So I can assume A here is the wrong answer, given this here. So this here is wrong. I can look at B. So here -5 and -8. So I have, again, y here, in this case is -8 here. Again, this is my y value. -8 is my y value here. And I can say it is less than -5 plus 1. So I have -8 is less than, I have -5, which is +5. 5 plus 1 here is 6. So this works out, right? 6 I know is greater than -8 here, which is great. And then let me just check the second restriction here. Y has to be greater than y has to be greater than x here. So -8 is greater than -5. In this case, this is not correct, right? I know that -8 here is actually less than -5. So this solution is not correct. So this order pair does not work. Let's try C here. So C here states that this is 0 and 0.5. So again, I have here, the y here is 0.5. It is less than -x is 0. So I have 0 plus 1 here. 0.5 is definitely less than 1 here. So this is good. And then is y less than x here. I have 0.5 less than x here, which is 0, sorry. And this here is also correct, right? Because 0.5 is greater than 0 here. So C is the only order pair that makes both inequalities true. So C here is the correct answer. I'm just going to check D for you real quick so we don't have two answers in this problem. I have 1 and -1 here. Y is, again, -1 in this case. It is going to be less than -1 here for x plus 1. -1 is less than -1 plus 1 here is 0. This will not be my solution, right? Because, again, 0 here is actually no, this here is correct. 0 is greater than -1. Sorry. And then, but I would have to check my my other solution, which is y has to be greater than x. -1 has to be greater than 1. This here is not correct here because -1 is less than 1. So D here is not correct as well. Therefore, C is my only correct answer. And they got this as well. C is the correct answer. That's good. Let me just double check their work. So option A, they did this. That was correct. 7 is 7 here is less than 5, not greater than 5. 7 is greater than 5, not less than 5. This holds true. That's good. But -8 is less than -5, not greater than -5. C is correct. And then D here is incorrect because -1 is not greater than 1 here. So the solution here is correct. Great analysis here. So this number 9, let's look at number 10. I think I have 11 questions for you, so maybe we'll finish both of these problems for today here. So how much is 168 centimeters in inches? So 168 centimeters to inches. So basically what we have here, these are units of length here. And units of length, they have actually a different system. So these are all measuring length here. But we have centimeters, which is in the metric system, and we have inches in the empirical system. So if we're converting between systems, we're going to get a different kind of number in terms of ratio, right? So I would have to basically figure out how many centimeters are in an inch. So centimeters to inches. So I need a conversion for this as well. So if I want to convert a centimeter into an inch, I would have to know that 1 centimeter here would equal 0.3937 inches here. And this is a conversion that we can do. Here we can also, it's basically 1 divided by 2.54, right? Or you can say 1 inch here would equal, if I were to flip it, it would be 2.54 centimeters here. So in order for us to do this, either way, both of these conversions can help us. So let's use maybe let's use the second one here, because that's what they give us here, 2.54. So if I know that 1 inch is 2.54 for centimeters, I can also say that I can figure out my conversion rate. So I have 168 centimeters here. If I want to convert centimeters into inches, I would have to put centimeters here at the bottom here. I have 2.54 centimeters in 1 inch, right? So again, my centimeters here cancel out. I'm simply doing 168 divided by 2.54 to figure out how many inches I have here. So 168 divided by 2.54 will give me an approximate value of this is 66.14 inches. And this here would be my solution for this answer here. And again, correct, right? The centimeters equals 1 divided by 2.54 inches per centimeter, basically. And then they're simply just dividing both of these numbers. Right? 160 divided by 2.54 gives us 66.14 inches, which this here is our correct solution for this problem. Good. And finally, for my last, I don't have a last question here actually. So I think I only pick 10 of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. Yes, I think I only picked 10 actually. So let me just let me see if I can pick maybe. We do have extra time, so maybe let me see if I can pick 1 or 2 more questions for us to do. Sorry about this. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I guess I did do 11 questions today. I did do 11 questions. Sorry about this. So let me pick out 2 more questions for you, and then we will figure those ones out as well. Let me pick this one here. Let me pick 3 of them. See if I can squeeze in 3 more questions here. And then I have these 2 as well. Okay. Let's do these 2 as well. Okay. So it says here, this is asking us, can square root of 34 be simplified? So I picked 3 more questions here. Can square root of 34 be simplified? So this is question 1 here. Saying, can the square root of 34 be simplified? So again, I'm going to take the prime factorization to figure out the roots here. 34 can be divided by 2. So simply just root 2 times, again, 34 divided by 2 here would be 17. I know that 17 here is my prime number, right? So this here would not be kind of simplified here. I have root 2 and root 17 here. 17 is a prime number, which means I can't actually take another prime factor. 17 itself is a prime factor here. So when you say, can square root of 34 be simplified, this here means it cannot be simplified here. Because again, I have 2 radicals here. I'm going to need, again, I don't have more factors where I can kind of break this number down here, this 17 here. So therefore, can square root of 34 be simplified? It actually cannot be simplified here. So this here, I believe they're supposed to say 34. 34 is one of the simplest forms. And then basically what they did here was they took the prime factorization, right? Or not, they took the, they used the method as solution, and what they did was they figured out the decimal place here. So this 5.83 would be basically the decimal value for square root of 34. Again, they did it 5, square root here is 25, that's good. 34 minus 25 here is 9. You double 5 here, which gets you 10 here, and you add 2 zeros here, and you figure out, how many, which number would go into both of them to get 90. Use 8 squared here would be the closest one. So you put 8 here, and you realize 108 times 8 here would give you 864. I double my value of 8 here, which gives me 16. So I have 116 here, and then I'm adding 2 zeros, and you realize that 3 here would give me the closest value to this. So 5.83 would be my value for the square root of 34. So this solution here is correct. That's correct. Cannot simplify square root 34 anymore. Much further, I'll say. Okay, so that's number 1. Let's look at 2. Pretty sure I can finish 3 questions. Again, 15 more minutes here. So how many feet are in half a mile? So again, this is this is in the empirical system. How many feet are in half a mile? So again, if I were to solve this problem, what I can do is, again, I know that 1 mile here equals 5,280 feet. So therefore, if I'm saying what's half a mile here, I can simply just write, okay, what's half here? Half a mile times, I know half a mile, I'm going to multiply it by, I have 5,280 feet per 1 mile here, right? So I can, the miles here cancel out, so I have simply feet left, which is good, because that's what I want as my answer. Again, I have half times 5,280 feet, which would give me basically 2,640 feet would be the correct answer for half a mile. So this here is my solution for number 2. 2,640 feet are in half a mile, and they got this solution correct. They simply just divided by 2. That's good as well. The solution is correct. Good analysis here. That's number 2. And finally, number 3. This will be definitely my last problem of the day. This is which of the following is always true about the angles of an isosceles triangle? So again, let me write down what an isosceles triangle is first. So first you have to figure out what is an isosceles triangle here. And again, isosceles triangle here is that, what you could do is you could actually look at it's multiple choice, right? So A here says all angles are equal. This A here is incorrect, because if all angles are equal, I would get a equilateral triangle. In which case, if all angles are the same, this here would equal 60 degrees per angle, right? So that's not correct. A is not correct here. B here is one angle is obtuse. If you have an obtuse angle here, that means you have an obtuse triangle, right? So if you draw something like this here has an obtuse angle here. This is an obtuse triangle, which is not an isosceles triangle. So B here is also incorrect. C here is one angle is the right angle. So if I have a right angle here, this is my right angle. This is simply just a right angle triangle, right? Or a right triangle here. And this is not an isosceles triangle. And finally, which means D here has to be my answer here, right? C is also incorrect. D here has to be my answer, right? If I have a triangle here, if two angles are equal together, if this here x equals x here, then this would be an isosceles triangle, right? The definition of an isosceles triangle is a triangle that has at least, or actually two angles as well. So A here is false. If any two angles are equal, then the triangle is isosceles, so not necessary for all angles to be equal. That's good. We have an obtuse triangle. That's good. We have a right angle. That's good. And D has to be true, right? So this here is a correct solution and analysis here. So finally, so this brings me to my end of my video here. Again, we did actually quite a bit of problems here. I think we did about 14 questions for today, which is awesome. We kind of sped through the solutions as well, because most of these questions are pretty easy, and we can actually figure them out in about 1 or 2 steps, which is awesome. Again, I'm going to stream it in about an hour from now, so again, noon Eastern time, and we're going to actually work on much harder problems, so in Algebra 2 and in pre-calculus problems. So we have kind of 10 questions for those as well. So I'm going to work with you through those problems at 12. You can feel free to stick around for that stream. So again, if you're here for the first time, again, you can definitely feel free to check us out. All our videos are posted on our YouTube channel at youtube.com/OneClass. You can feel free to like and subscribe there to keep up with our latest videos for teachers here at OneClass to solve our problems here. So again, this comes to the end of my video. Thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.